Hi, my name is James Gowan, and I'll be going over my lab 1 on charge tapes. So the purpose of this lab was to create pieces of scotch tape with excess charge and to determine the amount of charge as well as model the experiment using code. The main result that I got was that the charge tape was positive, and I also determined the charge shown right here, the number of electrons lost here, as well as the ratio of electrons lost to atoms on the tape, which is this number. So the physical principles that I used are Coulomb's law, given by this formula, in order to find the electric force on the tape as well as the amount of charge on the tape. I also used Newton's second law, given by this formula, to solve for forces under the condition that acceleration is 0. And then lastly, I used the formula for gravitational force to determine the gravitational force on tape. So to prepare the actual tape, I made 2 tapes with handles shown in figure 1, and then I basically just did figure 2. So I placed a piece of tape with the handle on the base tape, ripped it off to create a charge on the U-tape. So to determine the actual charge on the U-tape that was made, I put it next to objects with known charge. So 2 U-tapes together would repel, so that means they have the same sign. But a U-tape next to a negatively charged pen would attract. So that means that the U-tape was positive since opposite charges attract. So now on to the actual experiment. I basically had to recreate this diagram and measure the distance between this blue tape, which is tape A, and tape B, which is the red tape, under the condition that tape B would float. So in this experiment, the system was just the top piece of U-tape, tape B, and the surroundings were the bottom tape, tape A, as well as the Earth. So this is the force diagram for the red tape. Had an electric force upwards and a gravitational force downwards, both with equal magnitude since the tape is not accelerating, which we can see right here. And since it's not accelerating, we know that the 2 forces are equal to each other. And these are just observations that I stated in the previous slide. So my initial conditions are given here. So the tape had a length of 0.185 meters, a width of 0.02 meters. The distance between tapes was 0.015 meters, and the tape's mass was 0.0002 kilograms. And I declared all these constants as well as other constants that I needed for my program right here. So to actually calculate the various answers that I need, such as the charge, number of electrons, etc., I first found what Fg was. I set that equal to the electric force. I solved for Q to find the actual charge value, divided it by the charge per electron to find the number of electrons. And then to find the number of atoms, I just followed this formula. And then to find the ratio between electrons lost to atoms on the tape, I just divided the number of electrons from this answer, from this equation, by the answer from this equation. So this is my code. I basically modeled the equations and the calculations that I showed earlier. I created an R vector. I found what Fg was, which is the tape's mass times G. I found what Fe was. I printed out a bunch of stuff so that the answers would be easily read. I found the charge value given by this equation. Found the number of electrons, number of atoms, and the ratio. And then this is the result. This is what I get in the window for the code, and this is what's printed out with all the various values. So for this lab, the sources of error were that I treated a long tape as though it were a point charge, and I assumed that each U-tape had about the same amount of charge evenly distributed along the length of the tape. Some similarities and differences between the data and model predictions were that I basically used the same formulas and the same calculations for both, but in the model, so basically in the code, I assumed that no charge was lost, but in the real world, some charge was probably lost. To answer the what if question, if the signs of electrons and protons were flipped, nothing would really change about the observations. because signs are kind of theoretical. So yeah, and to answer the why question, it's important to handle the charge tapes as low as possible, because if the charge tapes come into contact with things such as my hands or other objects, the tape would lose their charge. And yeah, that's pretty much it. Thank you for watching.